Today's problem 51578. So this problem is about optimizing minimizing needed time. So basically there is a sequence of different colored balloons, and what is required to do is to make this sequence colorful. By colorful, authors mean there are no two balloons staying located next to each other and that have the same color. In this case, this one is not colorful, the question is how to make this sequence colorful by taking out balloons, and every balloon have different time to take out, and the question is like what's minimal time required, so like aggregate takeout time to make this sequence colorful. And yeah, that's what is given. So let me explain my approach towards this problem. So I'm gonna use this no. Should be working. No. Okay. It's not working, but I can fix it probably. Or not. Maybe yes or maybe no. Yeah, I can fix it. So let's assume I have A, B, A sequence, and then the needed time 1, 2, 3, 4, 1. So what I'm gonna do, I'm gonna split the sequence into the subsequences of the same color, and in this case it's gonna be this sequence, and then this sequence, and then I'm gonna calculate. So it's obvious that to join those sequences, let's say I know what's cost to make this colorful and what's cost to make this colorful optimal. Then joining those sequences and like what's the cost of making this colorful. Then joining the subsequences will take no time because by the definition I put the sequences in separate buckets because they have like different letters. So if every subsequence is optimized, I can just aggregate the cost of making every subsequence colorful, and then I can just sum it up and then return the result. So the first, so the formula I'm gonna use for the, let's say this one is vi, and like for the vector, and then I'm gonna use dp of I for the cost of optimizing, or like cost of making a sequence up to I character. So in the dp we're gonna save the cost of making sequence up to subsequence up to the index I colorful. So in this case, the cost of making this kind of subsequence just of I of A colorful is 0 because it's already colorful. Then for the A, for the next A, there are basically two options. I can either remove A, like take out A, and then get the previous cost of optimizing like previous subsequence. So it's gonna be so to take out A, it's gonna be 2, and then the cost of optimizing previous subsequence is gonna be 0, 2 plus 0, or I can keep A and remove all the previous letters in the subsequence. So keep A and then remove 1. If I remove this one, it's gonna be 1. So and here I should take the minimal, and minimal gonna be 1. So here B is different from A, so this one just one branch of the, so I keep B and then take the cost of optimizing the previous subsequence is going to be just 1, and then here also the same, B is different from A, then I take A and keep whatever the previous subsequence, yeah. And then here I can either take A and so it's going to be, and keep the previous subsequence, so it's going to be 1 plus 1, or I can keep A keep A and then take all the subsequence, like previous subsequence, so it's going to be so I keep in A, so I'm taking aggregate, it's going to be 4 plus 1, because I need to keep like accumulating. So in this case, minimum gonna be this one gonna be 2, this one gonna be 5. So minimum gonna be 2, and that's gonna be the answer, 2. So the formula for the dp of I equals if character I is equal character I minus 1, or otherwise character of I not equal character I minus 1. So if it's equal, I'm gonna dp of I gonna be minimal between I keep vi and then I take all previous, so sum of vj, let's say, where j from some start to the start of the subsequence of the same letters to the I minus 1, and then or it's gonna be vi plus dp of I minus 1. And then if the character of I not equal character of I minus 1 is going to be just dp of I minus 1. So because these formulas are local, so they only depend on the this comes sum, cumulative sum, and then this dp array. So cumulative sum, I can just keep the current cumulative sum and then add the current value. And then for the dp array, I can just keep the previous dp I minus 1 and then update the current dp. And then the result going to be dp of n minus 1, going to be the result, or like output. Okay, so let me code this one. So let's say have that mute that's equal 0. Let's say let mute dp equal 0, and then let chars equals colors chars, and then for character and I in chars enumerated, I'm gonna calculate dp cumulative sum. Okay, so let ref char equals, say, just a, or like just one. So if ref char, okay, that's not equal char, say char not equal ref char, then I'm gonna do it with cumulative sum equals 0. Then here use it, then cumulative sum gonna be needed time at I, then in the end I'm gonna do reassign pref char equals char, and then else. So dp stays the same, so dp stays the same in this case. I'm dating previous char, okay, and then here if they are equal, then dp equals the compare minimum between two values. So I'll have v of I plus if I is greater than 0 needed time. So the first one I'll take now, here is gonna be just dp plus dp, or I need to do cumulative sum. And then cumulative sum plus equal needed time I. Something like that. And then in the end, I wanna Okay, enumerate. Interesting. So I have this 493, then 889. And then it's B, B, A, oh no, B, 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 A. So here gonna be 4, or like DP, gonna be 0, then 9, take 9, or keep 9 and 4, so 4. And here take 3, so 7, or keep 3 and do 13, so 7. And here gonna be 7, and then gonna be either take 8 plus 7 or keep 8 and then where's cumulative sum in my equation here? Here, okay, plus, oh no, equals. Okay, cumulative sum here gonna be 8 plus 7, then or keep at this one and then 8. Not just cumulative sum. How about just this? Because I need not just cumulative sum but also the previous, like, so in this case in the cumulative sum I need to include the dp 7 here, and then cumulative sum gonna be 7 plus 8, something like that. So let's refine the formula. So I need to somehow so this one was not careful enough with this as I guess. So it's gonna be the here dp also s minus 1 plus this minimum. Yeah, probably I can I like a couple hours ago I was solving this and like it was natural for me, and now I don't understand like how I did that without like maybe I quickly found whatever like shortcut and forgot about that. So let's create this dp array. I'm gonna be let mute dp. I'm gonna be work gonna be vector if charles and also have let mute s equals 0. S equal I and then here so we're gonna save this, create this vector, and then let yes, I know what happened here. So I'm not updating dp here, but it's staying the same, yeah. That's fine. character not equal previous character. I'm gonna go cumulative sum. dp of I equals 0 plus if I greater than 0, then dp I minus 1. Plus if s minus 1 greater or equal 0, then dp s minus 1. No. Yeah, let's think about how we can solve this problem without this dp array and instead like use the dp number. I wanna think about this. I can say that let mute ref dp equals 0, and then here the ref dp a little bit better memory. I did solve this one. Interesting. So we're solving here. Cumulative sum charts result. If chart is equal, I'm gonna go cumulative sum needed time. I was accumulating the result in the DP in the result. Okay, makes sense. Okay, so if I'm gonna do this change, it's gonna happen. So as bytes, and like we assume that the first Unicode or like first letter of the alphabet are like mapped to 1 byte in Unicode, and that's why this one is okay. Into iter needed time zip into iterator. So it's gonna be byte, and then why I need into iter? Oh, what's gonna be if I gonna do this? It's gonna be data type let t equals. So this is iterator over bytes. What's here? Gonna be x. What zip does? So if I have like tuple, so zip s1 s2 characters. Okay, so it will. So if zip is applied into the iterator, what's gonna happen? So here zip is applied to the two iterators. And here 1 4 2 5 3 6 zip. So if they're doing this needed time, oh, I got it into iterator needed time. So oh, that's smart. So you see here gonna have a character from the colors, and T here gonna have a time at the current index. That's smart. That's smart. Okay, let's reuse this one. Best practices. So if I do This is pointless. Or whatever, like, I need to somehow also update the DP and then result here. Was I updating once? A little bit better, but still. No, the time is still kind of, I don't know what happened. Yeah, the time better and memory is better. Let's do another. Okay, this one is consistent. Okay, that's it.